Van der Waals interactions are weak, short-range interactions between two uncharged species due to permanent or transient dipole moments. Van der Waals interactions can also be referred to as London dispersion forces. So by transient, we mean short-lived. It's important to understand the terminology, to understand the defining characteristics of the force. So transient means short-lived. So essentially, we have a short-lived dipole. So how do we get this short-lived dipole? So what happens is that when we have two uncharged molecules and we bring them really close to one another, we know that electrons are spinning all around the nucleus. So let's say, for example, we have a carbon molecule and we have another carbon molecule. So these carbon molecules have an electron cloud all around them. We see a cloud of electrons, and these electrons are spinning. They're randomly circling the nucleus. So there must be a moment in time where there are more electrons on this side and less electrons on this side. Same goes for this carbon. There may be a moment in time where there are more electrons on this side and less on this side. So what happens is that induces a very short-lived temporary dipole. So let's say we have a carbon molecule and most of its electrons are currently residing on this side. And let's say we have a neighboring carbon molecule and its electrons are currently on this side. So what we can note is that the side with more electrons will have a negative charge. So we'll see a negative dipole moment here, a positive dipole moment on this side because it has less electrons. Over here we'll see a negative moment, dipole moment, and here a positive. So then we can note that there's a positive over here and a negative over here. That means there must be some sort of interaction between these two carbons because we've created this short-lived dipole moment, and this is essentially our transient dipole moment. So this is Van der Waals interactions. So when we get these dipole moments and these carbons start moving close to one another, the point in time where the nuclei are so close together that they begin to repel one another because the electrons are spinning. So that moment, the second before the nuclei begin to repulse one another, that interaction happening over there where they're pulling each other close, that is your Van der Waals interaction. Now, what's interesting about Van der Waals interactions is that if only one of the carbons had this dipole moment, this carbon that already has a dipole moment, it can induce a dipole moment on its neighboring carbon. So since this carbon has a positive charge, it's going to say, okay, neighboring carbon, I have a positive charge. Do you want to interact? So in this carbon, its electrons are going to go to this side, and it's going to gain a negative charge so it can interact with its neighboring carbon. So what's important to note is that these interactions are very short-lived, and it's happening very, very, very quickly because these electrons are spinning very fast. And if the electrons are spinning very fast, we're getting these instantaneous dipole moments that are very short-lived. Therefore, that's why we call them transient. So these types of interactions are very important for our nonpolar molecules, such as our hydrocarbons. This is how our hydrocarbons are able to interact with one another. And we'll see the importance of this in the hydrophobic effect. In the hydrophobic effect, we want our nonpolar molecules interacting with one another, and they are able to do that because of the Van der Waals interactions. So essentially, Van der Waals interactions are the short-lived dipole moment interactions between non-polar molecules that are uncharged. It's important to remember that these molecules are originally uncharged. It is because of their electrons spinning, the high density electron clouds, they are spinning so fast, and sometimes there's a moment where there are more electrons on one side than the other side. And by uncharged, I mean that the number of protons equals the number of electrons. So these compounds and atoms that interact due to van der Waals interactions, they're neutral, they have an equal amount of protons and neutrons. And that is van der Waals interactions.